For today, I can simplify rational expressions. Let's read it together. 1, 2, 3. I can simplify rational expressions. So we're getting to the last. I don't know if those of you that like to run miles, right? You run the track and you're on the last lap, and then your teacher's yelling at you. You've got so many seconds, and then you need to kick in that extra gear, right, and finish off strong. Those of you that really love running, right? Well, we're down to the last stretch with the algebra piece. Right now we're going to cover for chapter 10 is rational expressions and equations. And today starts getting fun-er. Yes? Yay. All right. Oh, it's not a word? Okay. Well, I just made it up. All right. Here we go. So, rational expressions, you need the Freire model, please. Get that ready. What are they? Rational expressions are algebraic expressions whose numerator and denominator are polynomials. Algebraic expressions whose numerator and denominator are polynomials. Rational expressions are algebraic expressions whose numerator and denominator are polynomials. Examples. 6 over g plus 4, 2x plus 1 over x squared minus 15x, and 2x plus 6 over x squared plus 5x plus 6. Copy those. All right, let's see. So the definition says algebraic expressions. Okay, do I have expressions here? Let's see. Yep, all three of them. Whose numerator and denominator are polynomials. Let me look at this one. This one's a 6, but it's still called a polynomial when it's mixed up with all of them, and it only has one term. So what is the name of that polynomial? It's a monomial. This denominator is a binomial. So yes, it's a polynomial. It's an expression. This one, we have a binomial here, same here. Right here we have a trinomial. So expressions whose numerator and denominator are polynomials. Let me show you some non-examples. Non-examples. Let me move this out of the way. We got 6 over g plus 4 equal to 2, x squared plus 3x plus 2, and negative 3 plus x equals 10. Okay, so think about it. Why are these non-examples? We already went over the definition and these examples. Think about it. Why are these non-examples? Think about it. All right, discuss it with your neighbors, please. Why are these non-examples? So, critical attributes. Write this down, please. They need to be algebraic expressions, number 1. And number 2, they need to have polynomials in the numerator and denominator. Everybody got it? So, steps. Write this down, please. Number 1, identify the excluded values. In parentheses, write the denominator equal to 0 and solve. Identify the excluded values, which is to write the denominator equal to 0 and solve. Step 2, check for the greatest common factor of the numerator and denominator. Check for the greatest common factor of the numerator and denominator, which is pretty much what we did on the warm-up, remember? And number 3, factor completely the numerator and denominator. And once again, don't forget about your BFF, which is the TCF. And number 4, divide out common factors, and at the end, simplify. Write that down, please. All right, so check this out, guys. Things to circle or underline. I want you to circle the word or the term excluded values. Excluded values. I'm gonna give you a definition right now. Also, make sure that for step 2, the very first thing we do is check for TCF on the numerator and denominator like we did on the warm-up. Okay, instead of just dividing by 2 or whatever the case is. Factor completely, we already know how to do that. We did that individually for each expression. Now we're going to be looking at rationals. From there, we're going to divide out common factors, and then at the end we simplify. They're simple steps. I know they're kind of wordy and they have some terms in between, but it's fairly simple. Okay, I'm not going to have you memorize these. We're just going to go straight to the example so you guys can get some practice with. Here we go. So vocabulary on the left-hand side, on the Q side, I want you to write excluded value. Excluded value. And it says, any value that makes the denominator equal to 0. Any value that makes the denominator equal to 0. Any value that makes the denominator equal to 0. Excluded value. Now, as you're finishing up the definition, I'm going to remind you why. We're looking at rational expressions, is that correct? Which means we're looking at fractions. At the beginning of the year, let me take you back when you were barely 2 weeks old in this Algebra 1 class. Aww. And then we covered some definitions for real numbers, and I showed you the definition for rational numbers. Remember that? And I flashed something on the screen that looked like this. And I said, remember that? Quotients. Quotients are any number that can be written as m over n, where m and n are integers, but n cannot equal to 0. So therefore, that's why excluded values are the numbers or values that make the denominator 0. Okay, that's the reason why it cannot be 0. When we get to equations, I'm going to show you what Ty was talking about in regards to asymptotes. Okay, but for right now, check this out. Copy this example underneath that. I want you to write example Q, just so that you know what an excluded value is underneath that definition that you wrote. Yeah, on the Q side. We're still on the Q side. I want you to write 3 over x. 3 over x. And I'm going to ask you the question. What could the values be of x? Think about it. What can I substitute here? However, I need to identify the excluded value. This cannot be what? 0. So check this out. So could my denominator be all real? Yes. But x cannot be what? This is called the excluded value. So box that, please. So whatever value that makes the denominator 0, it's called a what? Excluded value. Yes. It is a real number, but according to the definition for excluded values, it says any value that makes the denominator equal to 0, except 0. Okay. Everybody got it? Okay. Okay. Let's do some practice problems so we can understand. So on the right-hand side, copy example number 1. Example number 1. Example 1A, and I want you to write find. You don't have to copy the whole text, just write whatever I underlined. Find excluded values. And then write the expression 6 over g plus 4. Okay? I'm going to go over this one, pens down, and I'll show you how to find it really fast. So, according to the definition of excluded values, the denominator cannot be what? 0. So all the excluded values are the values that makes this what? 0. So therefore, check this out. To find them, I need to write g plus 4 equal to 0. To find which value will make it 0, so I solve for the variable. Minus 4, g equals to negative 4. So my excluded value is what? Negative 4. So you can write g equals negative 4, or just write excluded value. And eventually, when you start doing some more practice problems a little bit faster, you can write it like this. G cannot be equal to what? Negative 4. Everybody with me? Yes. just to clarify, right here we find the EV, which is my excluded value. This is the process to find the excluded value, right? Now that I found it, G is equal to -4 because I solved for G. My excluded value is -4. Is that correct? So what could the denominator be? What values could we substitute for G? All real numbers except what? Because that's what makes it 0. Are we there? Okay. Let's do another one. Example 1b. Copy this. Okay, example 1b. You don't have to copy the text anymore. Copy 2x plus 1 over x squared minus 15x. Okay. So let's do this one together. What could this not be equal to? 0. So therefore, we need to find the excluded values. How do we do that? We set this, the denominator, equal to 0. So I'm going to rewrite this over here. And I'm going to write find EV, excluded value. So I'm going to write x squared minus 15x equal to 0. Do we know how to solve these kind of equations? Yes. Okay. Step 1, can we find GCF over here? X. What do we have left? X minus 15. Set each factor equal to 0. So we got x equal to 0 and x minus 15 equal to 0. Is that correct? This times this is equal to 0, so we set each one equal to 0. Can we do anything else here? No. How about here? Yes. Plus 15 plus 15. X equals 15. So my excluded values are what? 0 and 15. What's another way of writing it? Check this out. Everybody look up. This is where some of you got confused. X could not be what? 0 or 15. Okay. One. All right. So copy example 1C, please. 1C. Example 1C. Y minus 2 over y squared plus 5y plus 4. All right, here we go. Let's do this one together. So to find our excluded values, we cannot have 0 in the denominator, right? That means we need to set this equal to 0. Y squared plus 5y plus 4 equal to 0. And we're going to find our excluded values. Do we know how to solve these kind of equations? Yes. Is there any GCF? No. So we open two parentheses. Power Ranger. We got positive 4 on top. 5 on the bottom. Factors of 4 that add up to 5. 1 times 4, or 1 and 4. So we factor the first term. This is y, and we got plus 1 plus 4. Okay? Turn to your neighbor, let them know what the next step is to solve this. Very good. Set each factor equal to 0. Y plus 1 equal to 0. Y plus 4 equal to 0. And now we can solve. Minus 1 minus 1. Y equals -1. Minus 4 minus 4. Y equals -4. Okay? These are my excluded values. Are we there? Okay. So what would be another way of writing that we cannot include those in here? Let's see. I'll take a volunteer. Yes. Y cannot be equal to -1 and -4 or -4. Okay. Now, why didn't I include 0 in this list? Let's see. If I substitute 0 in here, what is 0 squared?
0.
What is 5 times 0?
0.
What is 0 plus 0?
0.
What do we have left?
0.
4. So 4 is included. So the only numbers that I cannot include in here, if I was to substitute -1 in here, what do you think it's going to give me? 0. Let's try it so that you can see it. Why is it that we exclude it? Let's see. I'm going to substitute -1. This is -1 squared plus 5 times -1 plus 4. Let's see. This is 1 minus 5 plus 4. What is 1 minus 5? -4 plus 4.
Yeah.
That's why we do not include that number there. What would think will happen if I include the -4 in there? It's going to equal 0. Are we there? So far, so good? Okay. All right. Now, that's only part of it. Let's go to the next part, which is to simplify. Okay. Copy this down, please. Example 2A. 2A. It says, simplify each rational expression if possible. However, what is the second part? Identify any excluded value. So the first thing that we already know how to do is what? Identify excluded values. So let's do that. So what do I write? 14R equal to 0. So to solve that, to find, right now I'm finding my excluded value. To solve for R, I need to divide by 14. Divide by 14. R cannot be what? So the excluded value is 0. So another way of saying that we cannot include it is R cannot be 0. Okay, this is my EV. Okay, let's see. So far, so good? Okay, so check this out. Next, we need to simplify. First of all, let's identify the GCF between this number and this number. What's our GCF? 2R. So our GCF is 2R, 2R. That means we're going to divide this by 2R and divide this by 2R. So let's see. If we divided this by 2R, what's left? R cubed, is that correct? What's left here? 7. Once we identify our GCF, we can divide out the GCF. Why can we divide it? Because this over that becomes what? And what is 1 times all this? All this. So we're left with R cubed over 7. This is simplified. This is my excluded value. Are we there so far? Okay. Let's do another one. Copy this next one down, please. Example 2B, same thing. We're going to simplify and exclude, identify excluded values. So the first thing we do is identify the EV. So I'm going to write 2n plus 1 equal to 0, and let's solve. Minus 1 minus 1, 2n equals -1. What do we do at the end? Divide by 2, divide by 2, n equals to -1/2. So my excluded value is -1/2. What's another way of saying that we cannot include it? N cannot be equal to -1/2. Are we there so far? Next, let's look at this. Can we identify a GCF between these two? No. Can we find a GCF though for the numerator? Yes, what's the GCF for the numerator? 3n, and we're left with n plus 2. Oh, my bad. Plus 1, sorry. N plus 1. Is that correct? What's the GCF for this one? Do we have any? Did I make a mistake, or? Let's see. Oh, this is 2n, my bad. 2n plus 1. Thank you. For this one, 2n plus 1. So check this out. This is what I need you to do. When there isn't any GCF or any factoring to be done, I want you to write it with a GCF for these two. What would be the GCF for these two terms right here? 1. Okay. Now that we did that, can you identify the greatest common factor between these two? Yeah, which is this one. Do you see it? It's a giant 1. What is 1 times all this? 3n over 1, which is 3n, and we're done. Okay? So pretty much all you have to do is factor completely the numerator and denominator and get the GCF out of the way. So homework. Homework was on page what? 5. That's what page was it, guys? 646, numbers 1 through 31 odd. Have a good one, guys. Enjoy your homework. The video will be posted so you guys can go and get some help. Have a good one, guys. See you guys tomorrow.